Hello. This is hopefully one of the. We'll get to the financial model very soon, but this is a kind of putting some of the data together now. In an earlier file, we got this solar GIS sample data, which had detailed data. I think hourly data here. If we go all the way to 2012. We don't want to do that. How about we'll just go down one year? Okay, let's go down 8,760. Okay, and just look at a year's worth of data. Now I'm supposed to introduce these files to you. So what we'll do in this file is just compare this data to a couple of other sources and then get ready to just compute the yield and make a little use it to begin our financial model of this solar project. Okay, and we'll put some performance ratio statistics and other things in it. Okay, I'm getting to the end here of the first year. Okay, so should have done some kind of pivot table or something to get this year by year. That's very bad what I just did. Okay, so that's the solar resource. It's right. Interesting. This one is right at 1,000, and it's got some slope and all the rest of it. Okay, we didn't need that really. And then I think the you can see what I did here. And then it has the yearly sums. This is the average daily irradiation, and they get a average daily irradiation of 5.11. Now, what I did is then found the latitude and longitude of this. And whoops, I've got a phone clicked in here. How do I get rid of that? Okay, come on. And then, so this I'm sure is the by far the most accurate website. Of course, it doesn't have U.S. It's from the European Commission. You know, they in this case they had 5.21 compared to what we had is 5.11. It's not that different, although 5.11 would be a 5.22 would be a P85, so it would be only have a 15% chance if you believed all that data. So that's one place. Now, uh, the other thing I tried is to go to PV Watt. You know, they have a little map thing here, but it really just then goes to the closest place, so it doesn't have the same kind of accuracy. But that's 4.86. Now, if that's true, uh, why did I say that? That would be about a 1%. That would be a P99 according to the data. And then I went to RetScreen and I had to go to Granada and 4.75 in RetScreen, which would be further than a P99. So either the location is highly important or the uh, uh, data is just giving you some different results. I had the same kind of problem here with the Dubai in when I did this in Dubai. Here's the Dubai airport. Gives me a number of 6.38 per year. If you go to RetScreen, the Dubai airport gives you 5.25. So, okay, and so we have these kind of problems. Um, the okay, I meant to. Sorry about this. This is embarrassing. Let's now. So now let's take this data. Now what we really want to do is go through some this is in the chapter 4 in the slides. It's also, and I've got some temperature coefficients difference for thin film and other ones. And if you go, this is what a PV cyst looks like. And the nice one is, so it's got some various other stuff in the slides here, but it has the how much you're going to produce, then how much you're going to get from the tilt, then the big one, which is how much you lose from the temperature, and then all of these other losses related to soiling, related to inverter losses, related to other things. Okay, so let's just make some simplistic assumptions here. There's going to be some loss from a temperature coefficient here. Not quite this much, and then we'll put the other losses in. Now, just give me 1 minute here. One minute. Okay, let's. Here's what I did. I put some indicative kind of numbers about, and this would be in PV system. I'm not suggesting that you do this, of course. I put some numbers in, and I just want to show you a little Excel thing on this. And did we have some temperature things here? When we did ret screen, here was the temperature. This doesn't really help because you need the temperature during the day, don't you? And this was Granada. Here, look at the difference between Granada 5190 and ret screen Granada 4.75, and PV watt, I'm pretty sure that's Granada 4.86, 5.19, 4.75. That's not very good. And okay, well, whatever. And the temperature coefficients that we just looked at, let's just make a kind of typical calculation. How's that? So let's say we're using I don't know, SunPower 0.38. Here's these other people said that it could get up to 0.45, which is consistent with this one. Let's put, let's say the I don't know. This would have to be a weighted average temperature. So let's say the weighted average temperature is, I don't know, 30 degrees. Okay, and then the STC temperature, maybe 32. How's that? 35, 32. And then 25, and the coefficient is minus 0.38. Oops. Sorry. Okay. And then we can get our loss, which is just a percent loss. Now, so let's take this times this minus this. Oops. Just a minute. Oh, shit. This was 0.38%. Okay, so this is we have about, this is the loss due to temperature loss. I wonder if I spelled that wrong. Okay, whoops. And then let's you know uh, do this. Okay, and Shift Control P. Now here's what you want to do is put 1 minus this times 1 minus the next one, and that's going to take too long. Let's just make a quick function. Again, just to show you how to make the functions. Now I happen to have cheated, but we're going to don't look down there, and we'll put function compound. Call it series. And first let's define this compound as 1, and then for I equal 1 to series dot count. I hope I did that. Oops, I spelled it wrong. God. Okay, and then compound equals compound times, oh, you can see my spelling, times 1 minus series I. Okay, and next I, and then compound equal 1 minus compound. No. So that would, I think that would do it. So let's probably, I'm sure you saw a spelling mistake I made, and we can put total losses. Okay, equal compound, which shows up here. Select that, and it didn't do it right. I wanted a loss percentage, but it's not that bad. You know, let's see what I did wrong. Compound equals 1 compound equals comp. Let's see if that did anything better. Shift Control P, and that did worse. Shit. Okay. Compound. Okay. Sorry about this. Spelled the function wrong there. Okay, sorry about that. All right, so we get total losses of this, and this should have been a minus because we're expressing them all as losses. So we get a total losses of 11%. Now what we can do then is kind of, this is without the tilt. Shift right arrow, Control R. This is with the tilt. Is that right? No. Shit. This is, just a minute. Can't be that much more. 5.97 at the end. I meant to get this one. I didn't go down one. Maybe I did everything fine. Okay, and this is total. Now if we want the amount per year, oh shoot. Oh God. Okay, so this is our this is our total for the year with the tilt, and then we're going to have the loss and performance ratio, I guess, will be kind of the PR. Let's just put that as 1 minus this. I'm not sure that's exactly, whoops, 1 plus that. Okay, so 88%. So now let's, if we want to get this, why don't we get the capacity factor? I know some people don't like to call this, but we take this which is the daily, okay, and we must multiply this by 24 hours, no, by 365 days to get the annual amount, right? And this is in shit. So here we got the average. Let's put the average hourly. Okay, and then we get the, and I guess we can put it here too. No, let's do that later when we get when we get the total, okay? And then I was just thinking about something else. So sorry about that. Now remember the big thing here. The biggest thing is that this is at 1,000. It's tested at 1,000 watt hours per meter squared. So we can just divide this by 1,000 and get the capacity factor. The gross. I'll call this gross. Okay, and then once we have the gross capacity factor, okay, then we can get the yield, okay, which is just this multiplied by 8,760, okay. Oops. Okay, and then once we, okay, how about we'll call this the gross yield. Oh. Okay, and then we can put the less the losses. Okay, and really this is this thing times this, and we can get the net yield. Okay, which is, I suppose, this plus that, and we can get the net capacity. Okay, so I'm just going to take this and again divide that by 8,760. Okay, so that's a really good capacity factor. Whoops. All right, and if we do this now, that's very, very good. Now, okay, just about finished here. Let's make a little diagram of this. So, how about we put the yield without tilt, okay, and you know, why don't I'll use the capacity factor without the tilt, okay, and increase from tilt. Okay, Okay, and so what I'm going to do now, I should be telling you this, and we'll make a waterfall diagram out of this. So let's take this minus this, okay, and then gross yield. And we leave that blank because that's going to be a subtotal. And then we can put temperature loss. Then how about we'll just put all of these things in. Now, when we do all of these, and then we'll put finally net capacity factor, okay, and all right, and the only thing we have to do is make sure we compound it correctly. So let's take the first, let's just take this multiplied by the gross capacity factor. All right, oops, and put a minus on that. And why did this kind of come out so funny? I don't know why. And then now let's, we have to kind of compute subtotals, I think. We'll take this plus this. That's what we have so far. And then multiply it by that loss and put a minus. You know what might be best is if we put this over here. So then we have this times 1 minus this times 1 minus this. I'm tempted to make a new function out of this times the next one. So that's our next losses. And why don't I switch it off so you don't have to see me type all of those in. Okay, I just put a subtotal over here. That was much easier to do. Now once you have this, you know, the next thing to do is to go to the disk and then go to chapter number 1, go to scenario analysis, go to waterfall graph, get the waterfall final, okay, and once that's open, it says Shift Control V on the bottom. So then you can press Shift, select the two, Shift Control V, and let me see, I think we want this in percentages. Now, I had a little bit of a problem with a computer that has a dot comma and all that stuff. Let's include the vac. How about this? Let's try this. Okay. So it's computing here. It won't take very long. It goes fast after a while. Until I just screwed it up. Okay. So that shows you kind of how you get from the gross yield to the net yield. Okay. You know, we could push it a little bit tighter. So if you wanted to do that, what you do is you press Shift Control V. First of all, you make sure that it checks the delete other boxes, and then factor for line split a higher number. So we want a higher number here. Okay, let's put 10, 9. How's that? Okay. I don't know what happened that last time while I suddenly stopped the thing. Okay. Now you wouldn't have to do this again if we put a different. Okay, come on. If we put a different loss factor or something, or temperature coefficient in here, you know, uh, we get different numbers. So let's say it's 35. Okay, and let's say the I don't know where's the soiling. Let's say that the soiling is 2%. Okay, I think it put it in the back of the whole sheet, didn't it? And put some data, and then so it changed the losses, and then we get a different number. Okay, let me try something. I think I can move this chart. I've never tried this. Let's move this chart to an object in the summary page. Okay, oops, that didn't look so good. Perhaps we, okay. Can I make this smaller? Okay. And no, I don't want to do that one because that's going to mess everything up. Okay, so let's see. So let's change this to 40 degrees, which is not real. And then it changes. Okay. And okay. I think that's about right. Okay. So that's making our waterfall chart out of it. And now we kind of have a capacity factor. And let's take this. I guess we'd like the capacity factor to be different for different months. Now, I think all we can do is, you know, do not. We don't want to do a weighted average. We want to push it up sometimes, and so let's take this as a percentage of the average. Now, yeah, that's all. Okay, Control D, Shift Control P. Let's put another, insert another line, and then we'll put monthly capacity factor. Now and then what we'll do is take this monthly capacity factor and we'll put it in our financial model. Okay, it would be nice to put this. I don't know if you like this chart or not, but I kind of like it. You know, and we could put this. It would be kind of nice to put this in the okay. Whoops. Of course. This F4. Multiply that. Okay. Control down. Oops. Shift Control P. And then we have the data we really need for our financial model. And I'm going to stop this now. Now, the only thing I really haven't done yet also is we might want to get a P90 and a P50 for all of this stuff. And we computed from this. You know, you could argue I should have used the other data. We computed the P50s and P90s for the radiation and all this. But I think you can see that there's uncertainty associated with all of the rest of the losses and with the temperature coefficient. So we really need to put uncertainties associated with all of those factors to get the final P50 and P90 analysis done. And I'm not going to do that right now. I'm going to stop this tape.